Algebra 2. Today we are going to talk about rational expressions. So the last section, sorry, the video was kind of icky. I'm not sure why it did that, but this one hopefully will be better. I've tested it and it looks like it will be better. So a rational expression is a constant. So it's dividing or it's a fraction of two polynomials. So fraction, right, would be 3 over 4. Okay? So a rational expression is just numbers. Remember, this is some number. I just don't know what it is right now. And this is some number. So it's over a number. Okay? But we call it rational expressions because it's got polynomials. It's got variables. It's got adding and subtracting in it. Okay? So it's got polynomials in it. And so one thing to remember is that any value on the bottom of a fraction will lead to undefined values. You guys need to memorize that word, undefined values, since we cannot divide by 0. So here, looking at this one, okay, here is our fraction. Okay. We have to say the value that x cannot be, because if this equals 0, then this is not a fraction. It's not possible to divide something by 0, right? So if I say, hey, how many groups of 0 can 3 people make? Well, they can't. There has to be at least a group of one person, okay? Or at least one group of 3 people, right? That's a group with 0 people in it, okay? So what we're going to do is we're going to set this denominator equal to 0. And you can see that it's done up here. Okay, we know that it can't equal 0, so we need to find out what value x cannot be. Okay, so x in this case cannot be negative 2, because if this is negative 2, then we get 0 down here. Okay? So we're always going to talk about our restrictions on x, or our undefined values, when we're talking about rational expressions. Because remember, these are just division problems. So here the same thing, so 10 over x minus 5. We take this denominator, we set it equal to 0 and solve. Okay? So to evaluate a rational expression, so this is evaluate, so this is just solve a rational expression. We're going to substitute a specific number for every variable in the expression, and then we're going to simplify it. So this is just like back several years ago when you were told, hey, solve this if x is 2. So I'm going to plug that 2 in, okay, and I'm going to solve. I'm going to get 2 over 3. Okay, so remember, a rational expression is just some number. Okay? We are just working with polynomials, that can be a range of numbers, okay? Because when we're talking about polynomials and we're talking about rational expressions, we're really talking about graphs. And graphs, right, x could be, any number along this axis, okay? And it's going to give us some different value. Okay, so if x is 2, right, then it's going to give us the value of 2/3. Okay, we could plug for negative 1 in and get a value for it. Okay, but the thing is, we need to realize that these are graphs. Okay, so a rational expression equals, I forgot the S, 0 when its numerator is 0. So let's think about a fraction or a division problem. If I do 0, so 0, and I want to put them into 4 groups, well, I can't. There's 0 of them. Okay, so case, when we're talking about x that makes the expression 0, that means the numerator has to equal 0. So we're going to say x equals 0, so x equals 1. So when x equals 1, this thing equals 0. And we don't have to do anything with the denominator in that case. This is going to be really big as we progress, because what this means is whatever this graph looks like, okay, it touches the x-axis at 1. Okay? So that's our x-intercepts. Okay? Because remember, these are rational expressions. Okay, so if we were to put an equal sign there, then we would have some y value here. So if we put it equal to 0, right, right? Then we have our y, our f of x value. Okay? So a rational expression is undefined when its denominator equals. So that's what we were talking about up here. So here, we need to find the value of x that make the expression undefined. In this case, we don't care about the numerator at all. All we care about are these two parts in the denominator. Okay, so undefined denominator, okay, equals 0 is the numerator. Okay, x plus 1 equals 0, and x minus 5 equals 0. And you guys have already done this, okay? This is our zero product property. So we say if this whole thing equals 0, then the entire denominator equals 0, because these are multiplied. And if this whole thing equals 0, then the entire multiplied. Okay, so I'm going to subtract 1 from both sides, and I get x equals negative 1. I add 5 to both sides, and I say x equals 5. So x cannot equal, so notice I'm putting that little slash in there, negative 1 or 5. Okay, that would make this expression, or this rational expression, undefined. I can't do anything with it. Okay? So let's take a look at rational expressions. So once again, rational expressions are just fractions. Okay? It's just numbers. So here, okay, I have 9 over 24. I'm going to simplify it. So this simplifies, so 9 to 3 times 3. 24 factors to 8 times 3. And really, we could factor this 8 some more if we wanted to. But our goal here is to get it so that a numerator cancels by a number in the numerator. And remember, when I say cancels, 3 and 3, yes, they cancel, but it's a division problem. So 3 divided by 3 equals 1. Okay? So you need to remember that anytime you're canceling, it's really a value of 1. Okay? So let's take a look at this one. This is a rational expression. So I'm going to simplify it the same way I simplify fractions. X squared minus squared is an a squared minus a b squared. So we're going to get plus b minus b. Oh, a minus b, not 4. Okay? And then in the denominator, we have x plus 2. We can't do anything with it. Okay? Remember, these are each individual numbers. Okay? So x plus 2 divided by x plus 2, right? These are the same number. Because I plug the same x value in, right? If I plug 3 in here, I'm going to get 5. If I plug 3 in here, I'm going to get 5, because I would have to plug the same x value in. This is the same, because if I plug 3 in here, I'm going to get 1. So anytime they're exactly the same, I can cancel them. And my final answer then is just x minus 2. Okay, so we're finding equivalent fractions. That's what we're doing. Okay. So remember that only factors can cancel out. So this is an entire number, and this is an entire number. Biggest mistake I see is that students see an x, and they're like, oh, I can cancel that. But remember, if there is a plus or minus sign between it, it is one single number, and that's why you guys should get in the habit of putting these parentheses, okay, around your polynomial, so that oh, that's one number. I can't just pull it apart and start taking stuff out of it. The way you can simplify polynomials is by factoring. And so let's do some problems. Okay, so we're going to start with a basic problem. So this one right here, 3 times x to the 7th. Okay, well, 3 is 3 times 1. Okay, and then x to the 7th is 7 x's. Over 2, well, 2 only goes to 2 times 1. And then I have x to the 4th. Okay. So you can remember that when you are getting rid of exponents, right, and it's a division, so x to the 7th over x to the 4th is really x to the 7 minus 4, x to the 3rd. Or you can come in here and you can say, well, x divided by x is 1, x divided by x is 1, x divided by x is 1, and x divided by x is 1. So that's going to leave me with x to the 3rd on top, but remember I still have these numbers in here, these coefficients that I have to put in. Okay, so my final answer then is going to be 3x to the 3rd over 2. I need to figure out what value can x not equal. So I'm going to take this denominator and I'm going to put 2x to the 4th equals 0, divide by 2, and I 4th equals 0. If I take the 4th root of this, it doesn't matter what it is, right? we're going to get x cannot equal 0. And really, anytime you just have a constant with a multiplied by a variable or more than one variable, it's always going to be 0. Okay, you don't even have to really plug it in. Okay, so if in my denominator I had, if I had 3 over 2xy, both of these have to not equal 0 in order for the denominator to equal 0. Okay, so either this one or this one. So x wouldn't be able to equal 0, and wouldn't be able to equal 0. Okay? All right, so let's take a look at a little bit more difficult one. Here I have x squared minus 2x minus 3 over x squared plus 5x plus 4. Okay, so remember, we're factor, factor, factor. You have to be able to factor. Okay, this is a single polynomial, a single number. This is a single number. The only way that I can break those x squareds and out of there is by factoring this. So I'm going to find what multiplies to negative 3. So I get 1 and negative 3, or negative 1 and 3. And I need the pair that adds to negative 2x. Okay, so that means that's going to be one right here. So because this is a 1, I don't have to do all of my factor by grouping. I can just plug those right in. Now I'm going to do my denominator. Okay. So for my denominator, I need what multiplies to 4 and adds to 5. 1 times 4, negative 1 times negative 4, 2 times 2, or negative 2 times negative 2. Those would all equal that adds to positive 5, this one. So then I'm going to have x plus 1 over x plus 4. Okay. So now I'm going to do division, so I'm going to cancel x plus 1, right? So 3 divided by 3 is 1. 4 divided by 4 is 1. Any number, x plus 1 divided by itself is 1. We get 1 times x minus 3, okay, but we don't have the 1 in there, right? But it's important that you use this in case 1 is the only thing that's left on top. You need to understand that that's not 0, it's 1. Okay? So x minus 3, and then I have an x plus 4 left on the bottom. So that's my final answer. But I still have to find those defined values. So we have to go back to our original factored form. Okay? So before we've canceled anything, we need to set those equal to 0 and solve them. So x plus 1 equals 0, and x plus 4 equals 0. So I'm going to subtract 1 from both sides. I get x equals negative 1. Subtract 4 from both sides, and I get x equals negative 4. Okay? So those are my values. X cannot be. So my undefined values or my restrictions on x. Okay, let's go on ahead and do this next one. So this next one, I'm going to go on ahead and just use the rules here. So I have x 11 minus 2 equals x to the 9th. Okay? But now I have to deal with those numbers there. So 16 breaks down to 2 times 8, and 8 just stays an 8. And so 16 we could break down to 2 times 2 times 2 times 2, right, 5 times. And 8 we could break down to 3 times. Okay? Oh, so this is 4 times, sorry. 2 times 2 times 2, and this is 2 times 2 times 2. But if we can break it down and get a number that's bigger, that's the same, we can still cancel that. So 8 divided by 8 is 1. Okay, so it's going to be easier to do that versus writing, so 2, and then 8 is 4 times 2, and then 4 is 2 times 2. So up here you would have 2 times 2 times 2 times 2, like I said. And down here you would have, that breaks down to 4 and 2, that breaks down to 2 and 2, so you would have 2 times 2 times 2, and then you would have to do the division for all of those. And so you can either break it out completely, or you can break it out until you can cancel. So remember, for the numbers, it's just simplifying fractions, finding an equivalent fraction. Okay, so now my final answer is 2, and remember I did that x to the 11th minus x squared, and I got x to the 9th. Okay. All right, so let's take a look at this next one. So this next one, I have 3x plus 4. Okay. So the only way I can pull stuff out of this is if I can factor. So 3x and 4 have nothing in common, so I can't do anything with it. I cannot factor that. Okay. Now let's find and see if we can factor this one. So 3x squared plus x minus 4, well, it's got that 3 there, so I need to multiply my a times my c, and I get negative 12x squared. So now I need to find my factors of negative 12. So that's 1 and negative 12, negative 1 and 12, 2 and negative 6, negative 2 and 6, 3 and negative 4, or negative 3 and 4. I need the pair that adds to positive x. And remember, each of these have x's on them. I just don't write that usually. Okay, so that's going to be positive 4 and negative 3. Okay, so now I'm going to do that factor by grouping. Okay, if you have another method that you use, that's fine. Okay, I don't care what method you use as long as you know how to factor. Okay, so now when I'm doing my factor by method, my factor by grouping method, I take these and so it's still the same function, okay, but now I've just changed what it looks like. So now I'm going to go on ahead and put parentheses around the first two and parentheses around the okay, what can I factor out of this pair right here? Well, they have a 3 and they have an x in common, and what's left is x minus 1. Okay, 4x and plus 4, they have a positive 4 in common, and with x plus 1, okay. So, let's see, just a second. So, I put a positive 4 here instead of a negative 4. Okay, so how did I know something was going to be wrong? Okay, these two have to match exactly. And if I put, that would be a plus 1. Okay, if these two don't match, then you've done something wrong. Okay, so I look at this one and say, oh, this should be x minus 1. I actually do the work here, because if you've put, the wrong pair in here, okay, there's here. Okay. So now x minus 1 is one of our factors, and whatever's outside the parentheses is our other factor. Okay. So we have 3x plus 4 times x minus 1. Okay. So that's going to go on the denominator here. So 3x plus 4 and x minus 1. Okay, now let's cancel things that are exactly. This number, 3x plus 4, is the same as this number, 3x plus 4. Okay, now this is where I said, remember, when we're canceling, this divided by this is really 1. So we have a 1 on top, and we have that x minus 1 in the denominator. Okay. But we're not done yet. We still need to find the restrictions on x. Okay, so we're going to go back to this one right here, okay, our factored form, and we're going to set both of, or all of, if there's more than 2, those factors in the denominator to 0. 4, so we get 3x equals negative 4, divide both sides by 3, and we get x equals negative 4 over 3. So x cannot equal negative 4 over 3. If we add 1 to both sides, we get x cannot equal positive 1. Okay, so our restrictions are x cannot equal negative 4 over 3 or positive 1. Okay. Okay, let's take a look at a couple more. Okay. So 6x squared plus 7x plus 2, so the very first thing I'm going to do, put parentheses around them. Okay, this is a trinomial. I can't just start crossing stuff out willy-nilly. This is a trinomial. Okay, so let's go on ahead and factor this. So I'm going to do my first one. I'll do it over here. So a times c, so this is this one, is going to be 12x squared. And I'm looking for the pair that adds to 7, so 1 and 12, negative 1 and negative 2 and 6, negative 2 and negative 6, 3 and 4, negative 3 and negative 4. Okay, and if you know the list and you know right off the bat exactly what it is, that's fine. Write it out so that you guys can see. And sometimes you'll have numbers that look like they add to this. Like if one's positive and one's a negative, and you make that mistake, that's where these won't match. Okay, so that's where you would go back to your list and double check that you chose the right pair. Okay. All right, so now let's go on ahead and write it out. 6x squared, instead of 7x, I'm going to put plus 3x and plus 4x, and then I'm going to put that plus 2 at the end. I'm going to do my factor by grouping. Okay, so here, this has an x in common and it has a 3. It's going to be 2x plus 1. Here, this has a 2 in common. So that's going to be 2x plus 1. These match. I know I'm good. And there's my other pair. So 3x plus 2 and 2x plus 1. So I'm going to go on ahead and write those on the top, 3x plus 2 and 2x plus 1. There's my numerator. Okay, my denominator, I'm going to do the same thing. I'm going to multiply these two. So I'm going to get negative 36. Okay. And this time I'm going to do it a little bit different so that you guys can see how it would work. Another way of factoring. Some teachers teach it one way, teachers teach it another way. Okay, so I've multiplied those two, so now I'm just going to rewrite this whole thing as x squared minus 5x minus 36. So the same thing now. I'm looking for the pair that multiplies to that and adds to that. So 6, let's see, I would start with, I don't know, like 6 times 6. You know, you can start with 1. Okay, so it has to be negative, so at least one of those would have to be negative. Well, that doesn't work. Okay, well, 9 times 4 I know works. If one of them is negative, it's going to have to be the bigger one to get that sign. And negative 9 plus 4 is negative 5. Okay, so that's going to be my pair right there. So now I'm going to go on ahead and I'm going to rewrite this as x minus 9, okay, x plus 4, and if I can divide anything. So I'm going to put this 6 back in there, okay, and I'm going to see if I can divide anything out of those. Okay, so here I can divide a 3 out, and I'm left with 2x minus 3. Okay. And here I can divide a 2 out, and I'm left with 3x plus 2. So that's another way of factoring. It works the exact same way. Okay, it's just a little bit different method than this one. Okay, so the important thing here is to remember that you take that 6 out, but then you have to put it back in and then simplify these two. Okay? So you're doing the same thing, it's just a different method. Okay? So now that's going to be, my denominator is going to be 2x minus 3 and 3x plus 2. Okay? I'm going to cancel anything that's exactly the same. And so I'm left with 2x plus 1 over 2x minus 3. Okay? Remember, I can't cancel these two x's because they're part of a group. So 2x itself is not the number. 2x minus 3 is the number. 2x by itself is not the number. 2x plus 1 is the number. Okay, so remember, that's as far as I can get this thing. Okay, but now I have to set my denominators equal to 0 and solve. Okay, so I'm starting to, use a lot of space here. So I'm going to go back to my first 4 I canceled, and I'm going to set 2x minus 3 equals to 0. And I'm going to set 3x plus 2 equal to 0. Add 3, and I get 2x equals 3. And when I divide, I get, I'll write it over here, x cannot equal, so that's a 3 over 2. Okay. Same, subtract 2 from both sides. And you guys will start doing this so much that you'll be able to do it in your heads. But for now, I recommend writing it out so that you don't make a mistake. Okay, we're going to divide by 3, so that's going to be negative. Okay, so those are the values that x cannot equal. All right, let's take a look at the next. So the next one looks like it's going to be a little bit easier. Okay, draw some lines here to separate them. All right, so 2x minus x squared. X out of that, and I'm left with 2 minus x. Well, let's factor this one. What multiplies to negative 2 and adds to negative 1 is going to be negative positive 1, so that's going to be x minus 2 and x plus 1. And looking at this, it doesn't look like there's anything that can cancel. But notice that they are very similar. Okay, they both have a 2, and they both have an x. So I need to find a way, if I can, to make them look exactly the same. Well, if I divide this whole thing by negative 1, right, so that negative 1 is going to come out with that x. From there, I'm going to get negative 2 plus x, which I can write, right, as, so this would be a negative x, and I can rewrite this as x minus 2. Now I'm going to put these back under, so x minus 2 and x plus 1. So now those two are exactly the same and cancel. Okay, so sometimes you want to look at ways to see how can you make it look exactly the same if they're really close. Okay, so if the coefficient on the x is the same and if the constant is the same, okay, then the probably pull out a negative sign and change it. Okay, so you really want to check for that, if you can pull out a negative sign. So my final answer then is negative x over x plus 1. But I'm not done yet. I have to set my denominator, my factor denominator, equal to 0, every single part that has a variable in it. And I'm going to do, so I'm going to get x cannot equal 2, and minus 1 cannot equal negative 1. And you've noticed that sometimes I write it like this and sometimes I put them together. It's fine either way, right? X just cannot equal either of those. And let's go ahead and take the last one. So 10 minus 2x, I can take a 2 out, and I'm left with 5 minus x, and here I have x minus 5. Okay? So those are numbers. Remember, these look really close. So the constant is the okay? And we have a 1 for the quotient in front of the x. So anytime I see that, I'm going to think, oh, I can pull out a negative. Okay, so if I pull a negative out, then I'm left with negative 5 plus x. And I pulled this negative way over here because I can't forget I have that 2 right there. Minus 5. Well, this can be rewritten as x minus 5 over x minus 5. So when you cancel, you just get negative 2. But now I have to find out what can my not be, so I'm going to go back to my factored form. So in this case, I can say x minus 5 equals 0, add 5. Okay, so x cannot equal 5. Okay, so that is it for simplifying rational expressions. Once again, you guys have to be able to factor. If you are still struggling with factoring, you need to find some videos and or ask for help, because you have got to proficient at that. Okay? So make sure that you can factor for the rest of this chapter. Have a great day. Next time.